Okay, a very good morning to all of you. Today's topic is functional equation. Now, functional equation, I want to just clarify something. Functional equation is very important for JEE Advanced. Is very important. It comes in JEE Advanced regularly. In JEE Main, in recent times, there are some questions which are coming. But if you ask me overall, I would say that for JEE Advanced, Chennai Mathematical Institute, for these exams, it is very important. So what is the topic all about, functional equations? You see, we are used to doing differentiation when one function is written explicitly in terms of another, one variable is written explicitly in terms of another variable. So if you write y explicitly in terms of x, then you say y is a function of x. So we are used to doing differentiation like that. That's how we do differentiation. But the thing is that suppose if I give you an equation which is involving the function and in which both x and y are there, then we are not immediately sure that whether x depends on y or y depends on x. So such an equation, we call it a functional equation, and we can choose any one as the dependent variable, any one as the independent variable, and we can do some calculations. How do we do those calculations? How do we solve the sums? So we'll just see one example, and then I'll of course give you the homework questions. So let's have a look at the example. So there's a function f which maps real number to real number. So the function is given by f of x plus y is fx into fy, and you are informed that fx is not equal to 0, and you are informed that f dash 0 equal to 2. So there's a function f which maps real number to real number. F of x plus y is fx into fy. Fx is not 0. F dash 0 is 2. You have to show that f dash x is twice fx. You have to show this. And after that, the next part of the question is you have to find fx, right? So first you have to show that f dash x is twice fx. The next part of the question is you have to find fx. This is what you have to do. So let us see how to do this question. So the first thing you have to do is you have to differentiate both sides. So this is the equation. The first thing you have to do is you have to do differentiation of both sides. So if you differentiate f of x plus y, then the derivative of x plus y will be 1 plus dy by dx into the derivative. I am writing it as f dash x plus y. Now let's go to the right side. So right side, you are getting derivative of fx into fy, so f dash x into fy plus f dash y into dy by dx into fx. So after differentiating both sides, the left side will be 1 plus y dash into f dash x plus y. Right side will be f dash x into fy plus f dash y into dy by dx into fx. So what I have done is that for the time being, I have taken y as the dependent variable. So I have differentiated both sides with respect to x, as you can see. But remember, this is a functional equation. So y is not explicitly written in terms of x. So what you will have to do is, you will have to put dy by dx equal to 0. Okay, you will have to put dy by dx equal to 0 because y is not actually dependent on x. So you have to put dy by dx equal to 0. Secondly, you will have to make some more changes. You put x equal to 0, right? You replace x with 0 and you replace y with x. So you have to make all these changes. You put dy by dx 0, put x tends to 0, and you put y tends to x. So this will become 1 plus 0 into f dash. You have to put x as 0 and you have to put y as x So you will get 1 plus 0 into f dash x is f dash 0 into fx. So ultimately f dash 0 divided by fx equal to f dash x divided by fx equal to f dash 0. So f dash x by fx is f dash 0. Then you integrate both sides. So dfx by fx is equal to f dash 0 dx. So log fx to the base is x into f dash 0 plus c. So this is what we got. Now you use the fact that f dash 0 is 2. And how do you find f0? You just put x equal to y equal to 0. So f0 square is equal to f0. So f0 is either 0 or 1. Okay, but f0 cannot be 0 because fx is not 0. So that means f0 is 1. So if f0 is 1, then log f0 will be log 1, which is 0. So we are getting c equal to 0. Now go back here and just put f dash 0 equal to 2. So log fx base c will be 2x. So we will get fx is e to the power 2x. So log fx to the base c will be 2x. So fx will be e to the power 2x. So once we have got fx is e to the power 2x, so once we have got fx is e to the power 2x, now it's very easy to check this. F dash x is 2fx, so f dash x is 2 e to the power x and 2fx is 2 e to the power 2x, so both are same. So this technique is called functional equation. So let's summarize what was the discussion, what was this topic all about, functional equation. Let's just summarize. So first of all, one functional equation will be given to you. What do we understand by functional equation? That means there is no explicit relation of y with respect to x. You just have one functional equation which relates both x and y. So in that functional equation, you have to first differentiate both the sides. So if you differentiate both the sides, so 1 plus y dash into f dash x plus y is f dash x fy plus f dash y divided by dx into fx. Now if you put dy by dx equal to 0, and if you simultaneously put x equal to 0 and y equal to x, then what will happen? All the y dash will become 0. I mean dy by dx wherever is there, it will become 0. And you have to replace x with 0 and y with x. So f dash x by fx is f dash 0. That is what we will get. So dfx by fx is f dash 0 dx, integrate both sides. So log fx is x into f dash 0 plus c. So you replace x equal to 0. So log f0 is 0 plus c. So c will be 0. And by the way, f0 will be either 0 or 1, which is not, f0 cannot be 0, so f0 will be 1. So that means c will become 0. So log fx base c is 2x, so fx is e to the power 2x. So this is the way to do functional equation. And now I'll give you the 5 homework questions. So if fx plus y is fx into fy, f5 is -2, f dash 0 is 3, find f dash 5. This is question number 1. Okay, so now I am giving all of you the 5 homework questions from functional equation. First question, f of x plus y is fx into fy and f5 is -2. Okay, f of x plus y is fx into fy, f5 is -2, f dash 0 is 3. Question is find f dash 5. Okay, f of x plus y is fx into f5, f5 is -2, f dash 0 is 3, find f dash 5. Question number 2, f of xy is fx plus fy, prove that fx is k log x. This is question number 2. Question number 3 part A, f of x plus y is fx into fy, f of x is 1 plus x gx and limit gx extends to 0 is 1. So you have to prove two things. First you have to prove that f dash x is equal to fx, and second you have to prove that fx is e to the power x. Okay, once again question 3, there are two statements given. F of x plus y is fx into fy, fx is 1 plus x dx and limit gx extends to 0 is given as 1. You have to prove f dash x is fx and fx is e to the power x. Question number 4, f of x plus y is fx plus fy. We have to prove two things. F dash 0 is f dash x and twice fx is x into f2. Question number 5, f of x plus y by 2 is half of fx plus fy. F dash 0 is -1, f0 is 1. You have to find f2. So these are the 5 homework questions and you can submit your homework by 9 p.m. tomorrow. That means 9 p.m. on Tuesday. That's it for this session. I'll conclude now.